So welcome to the Grade 6 Math Introducing Integers webinar that we're doing today. This will be linked in the Grade 6 Numeracy, the number long-range planning document. You'll be able to find it under the learner outcome number 1. It'll be obvious, it'll have a little CSD indicator there, so you'll be able to watch it at any point in time, and it'll also have the link to the slideshow that we are using today. Now, one of the reasons I chose to make introducing integers a focus for one of our webinars is because when we took a look at our MIPI results, we're struggling a lot around that concept of integers and operations of integers. Now, of course, that's grade 9 results because this is the first time that we're actually doing integers in grade 6, being this is the first time we're implementing the new curriculum. So it's one of the reasons I thought I'd kick off with this one so that we can do integers nice and slow. And as you know, I'm a firm believer in doing that cyclical process. We'll just do a light introduction. And then as we progress throughout the year, we can start digging in deeper and getting a little bit more abstract with the work that we're doing. So what I'm going to be showing you is actually something called Piles and Holes that was created by James Tanton. He is amazing. I forgot to include a link in the slideshow, but I will do that so that you can go right to his website. He's one of those people who believes that anybody can learn mathematics to high levels at very young levels. So he does a lot of work with younger students, but doing high-end math stuff. So I love him. He is amazing, and I definitely recommend checking him out. But this is basically based on his work. I've tweaked a little bit, especially as we get into the later ends of it. But if you look at his work, you'll see a lot of similarities here. Now, I've put this together as a slideshow that you can present in front of kiddos, but I've only done like one example or two examples of each piece. Obviously, you wouldn't do everything we're doing right now in this half-hour webinar with kiddos in half an hour. You're going to stop after an example, and you're just going to throw more examples out there. The slideshow is kind of just a crutch for you. It's a major crutch for me because I have short-term memory issues, and I wouldn't remember what questions I'd want to do with you, and I'd want to do a nice progression, so it's there for you, but just throw out more questions as you do it. The other thing that I'd like you to know is actually I did this with our 7 to 9 PLC yesterday, and through their feedback, we tweaked it a little bit to make it a little bit easier and make it a little bit more sense, knowing that we're going to do the same idea with using those integer tiles, the black and red ones, that you can flip, or integer chips or other manipulatives, whatever you want to use. But you can repeat this exact same process, and then just after you've done that, go more complex with kiddos. But it's all about slowing it down and not rushing it. All right, so we're going to pretend that in front of us, we've got this sandbox. And if you know anything about mathematicians, we tend to be a little bit OCD. So we like everything to be nice and neat. So we flatten it out if we can. And when the sandbox is perfectly flat, we're going to call that the 0 state. It's like our Zen state, but it's our 0 state. And what I'd like you to do is imagine, and it's actually better if you take a piece of paper. What I would do is I'd give kiddos whiteboards, but I'd like you to draw your line and then draw a little pile of sand in there. So it kind of looks like the little pile of sand I've got. So I'll give you a moment to do that. Okay, so that little pile of sand, we're going to say that that has a value of 1. So 1 pile of sand. Then I'd like you on your piece of paper is to create another pile right beside it, not on top of it, but right beside it. So we've got our second pile of sand that you've drawn. So all together, you need to mute yourself. Perfect, thank you. Okay, so we've created another pile of sand. So what do we have? We have a total of 2 piles of sand, or we could label that as 2. But we're going to live in the language over the next half hour of 2 piles anytime we see that number 2 there. So if I start with 2 piles, so you've got your 2 piles drawn, and I'd like you to add 3 more piles now. So draw 3 more piles beside your first 2 piles. If you want, you can leave a little bit of a space to help you see what you started with and what you've built now. So we have our 2 piles of sand we started with, and we've added 2 more piles. So how many do I have altogether? Well, I have 5 piles. I have the 2 piles I started with and the 3 piles I added for a total of 5 piles. And if I want to leave out the word piles, I can just say 2 plus 3 more that I've added is a total of 5 piles. So 2 plus 3 equals 5. Seems pretty simple, but we always start nice and simple to make sure everybody's on the same page. All right, but here's the beauty. When you're in a sandbox, you don't just have piles of sand, you've got holes, and we can call these opposite piles. So we would also reference this as opposite 1. Now I'd like you to take a moment and ask yourself, if I have a pile and I've got an opposite pile, what do I notice? Well, I notice that I could take that pile and I could use it to fill that opposite pile. Because like I said, mathematicians can be a little bit OCD. We like nice flat states. So I'll fill that, and I've taken that one pile and that opposite one, and now I've filled it and I've got a 0 state. So I'm in my Zen again. So what I'd like you to do on your piece of paper or your whiteboard is to draw a picture that shows 2 plus opposite 2. And then when you've drawn 2 plus opposite 2, explain, or in this case, prove to me, use your arrows, why that equals 0. Okay, so you should have drawn something like this. There's my 2 piles and my opposite 2 piles, which we also know are called holes. And I can fill one pile into each hole, and I now have no piles, I have no holes, I have my Zen state. So my 2 plus my opposite 2 equals 0. So this time I'm going to give you 10 seconds to create a new situation different than the 2 we've just created that would allow you to have a 0 state. So create some piles and some opposite piles so that you have a 0 state. So maybe you drew 3 plus opposite 3. So 3 piles and 3 opposite piles. Maybe you drew 5 piles and 5 opposite piles. Okay. So Daphne has been doing this for a little bit, and she says, you know what? 3 plus opposite 2, so 3 piles plus opposite 2 piles equals 1 pile. We do know she's correct, but what I'd like you to do is draw a picture that will demonstrate, that will prove to me that 3 plus opposite 2 equals 1 pile. So go ahead and take a few seconds to draw that. So you might have drawn this one. So there's my 3 piles, and there's my opposite 2 piles, and your proof isn't just leaving it like that, but actually drawing the arrows to show that you've taken a pile and filling it, taking a pile and filling it, and when you're done, you're left with 1 pile. So yes, Daphne is correct. 3 plus opposite 2 is equal to 1. 3 piles plus opposite 2 piles is equal to 1 pile. Now, Harold says that 5 plus opposite 7 equals 2 holes. Is he correct? Go ahead and draw a picture that will prove that 5 piles plus opposite 7 piles equals 2 holes. All right, so you might have drawn something like that. Now I don't have all my arrows drawn in here in order to show the filling of the holes. I'm hoping you did because you want that proof in there. But we can see that 5 plus opposite 7 will leave me opposite 2, which is also known as 2 holes. All right. I'd like you to think about this question. What is the opposite of a hole? So I'll give you a moment to think about that. Maybe you drew it, maybe you visualized it, maybe you just talked yourself through it. But let's take a look. Here we've got a hole. Well, what's the opposite of a hole? Well, the opposite of a whole is a pile. And the opposite of a whole, so the opposite of what I just created was another whole. So the opposite of a whole is a whole. And you might be wondering, what does this really have to do with integers? But it's this connection to nature that we can play with, the connection to their understanding of piles and holes and sandboxes, but we will get to the abstract aspect of integers. But we're going to go nice and slow. This is a really tricky concept. All right, here's another one for you. What is the opposite of the opposite of the opposite of three piles? Okay, hopefully you had a chance to do that. Again, we have a half an hour to explore something that we would spend a lot of time with students and questions and how do you know, and walk me through how you figured out what the opposite of the opposite of the opposite of three piles is. I'm going to show you the zip through version. But if I've got three piles, well, the opposite of the three piles will be three holes. And the opposite of the three piles will give me three piles. And the opposite of the opposite of the opposite of three piles will give me three holes. That was a tricky one. All right. So really, the opposite of a counting number, so we've been talking about the opposite of piles, opposite of three. The real name for that is a negative number. And instead of writing op for opposite, we're actually going to use the little dash that we use to explain that this isn't a pile, that this is a whole, that this isn't a pile, but this is the opposite of a pile. So let's take a look at what that means. So if I write the number 2, what I'm actually building or I'm picturing in my head or I'm verbalizing out loud is 2 piles. So then what is opposite of 2? What is dash 2? What is negative 2? Well, that's going to be the opposite of 2 piles, which is 2 holes. Okay, I'll give you a moment to think about this one. So we've got the opposite of 2, which is the opposite of 2 piles, which is 2 piles. And students might go through it as saying, well, it'd be the opposite of 2 holes. They'd make that intermediate step, and then they'd say 2 piles. Either way is fine. What about negative 1? Well, that'll be 1 hole. Or they might have started by saying it's the opposite of 1 pile, which is 1 hole. Nice. All right. So let's take this a little bit more abstract. I don't want you just to run the math on this. I want you to draw this out and prove it like we did in the beginning. I'd like you to draw negative 3. So what does that look like in the terms of piles and hills? And then I'd like you to draw positive 7. What does that look like in the terms of piles and holes and hills and sandbox? And when you're done, go ahead and fill it. And then you can figure out what your actual answer is. Let's see. Did you draw something like that? And then did you fill it in and end up with just 4 piles? So 3 holes and 7 piles, when I fill them all up, will leave me with 4 piles. All right. Now I've been putting those words, when I look at this one, I was saying negative 3 is 3 holes and positive 7 was 7 piles. This time I'd like you to verbalize it first. So what does 3 plus negative 2 mean in the terms in the world of piles and holes and sandboxes? Then draw the 3 and then draw the rest of it and then use your arrows to show what it means and then figure out the answer. So do all those steps. I'll give you about 15 seconds. So I've got 3 piles, and I've got 2 holes. So there's my drawing of it. And when I use my arrows to fill it in, I will be left with 1 pile. So hopefully that's what you came up with. All right. This time I don't want you solving it all. This time I'm going to give you a series of expressions, and I want you just to tell me, will there be more piles or will there be more holes? So it's a beginning sense of estimating without actually doing any number work. You don't have to do any, come up with an answer for this. Here we go. Here's your first one. So I have 5 piles and I've got 7 holes. I will end up with more holes. What about this one? And yes, I guess I need to remove that equals 4. My apologies. So I've got -3, which is 3 holes, and I've got 7 piles. I will have more piles. What about this one? So in this case, I can see I have 7 piles and I've got 9 holes, so I'm going to have more holes. Here's a trickier one. So I have 14 piles and I've got 15 holes. I will have more holes. Here's your next one. So when I look at that, I could do what I did with the previous one and go 2 piles plus 2 piles plus 2 piles and 6 holes plus 6 holes plus 6 holes. But as I'm going through this, I'm going to use my sense making. Oh, got 2 piles and 2 holes. Well, that'll zen out. 2 piles and 2 holes, that zens out. 2 piles, 2 holes, that zens out. Oh, I have nothing left. I actually have my zen state for that one. And then here's one more. So I can see I only have holes here, so I'm going to have lots of holes. Oh, so my apologies. This was supposed to be animated. So if I take a look at the very first one, if I have 1 pile, I would represent that as 1. So I guess I'll just walk through this. I'll fix this for the actual slideshow. But what would -1 be? That would be the opposite of 1 pile. So then what would that third one be? What would be the representation of the 1 hole? That would also be -1. On the right, I've got 5 is 5 piles. -5 equals opposite 5 piles or 5 holes. So I want you to think about all of that and now draw this representation. See if you can figure out what that might look like in the terms of piles and holes. All right, this one was a tricky one. There's a couple ways that you could actually look at this one. When I did this with the other group yesterday, what we did was we explored the idea that I'm starting with my 5 holes, and then we looked at that -1 or -1 as removing a hole, but it actually became more challenging for them when the question became more complex. So I would actually argue that before we move to that stage where we talk about removing a hole, let's actually look at that subtract -1. Instead of looking at it as subtract -1, look at it just as -1. Opposite, opposite 1. Opposite, opposite pile. What is an opposite, opposite pile? That is a pile. So why would we not just represent 5 holes and a pile instead? So instead of looking at it as an operation there of subtraction, just look at it as 2 situations, my 5 piles and my 1 hole. And once I've done that, then I can look at filling that pile into the hole. And you'll notice when I did this, if I done it properly, in the next example, it will be better because I do know it is animated. But starting with that number string of those statements of the 1 equals 1 pile and the -1 equals 1 hole, using the examples previously before actually getting to the visual helps them see this a little bit. But the first one might be trickier. But once you've done this, can you see the 5 holes and the 1 pile, and why I was able to put a pile there? So let's look at the next one. We'll do the animation properly this time. So if I've got 1, that's representing 1 pile. We know that. What does this one represent? Take a moment to refresh your brain. Well, that's the opposite of 1 pile, which is 1 hole. What about this one? Well, that's the opposite 1 pile. They might intercede and say that's the opposite of 1 hole, and that's 1 pile. What about 5? Well, 5 is 5 piles. So then use all of those ideas to represent this one. So 5 and opposite 1. I'll give you a moment to just draw it. And if you have time, go ahead and draw your arrows and solve it. So you probably should have started by drawing 5 piles and the opposite of a pile, which we know is another pile. So I've got my 5 piles and I've got my 1 pile. And here now you can start to see, and kiddos can start to see, why is subtracting a negative? Why is that really just adding the opposite there? I rushed too soon to go into the 0 pairs when I was doing this with the other group, which is why I would slow it down, and instead of making it an operation symbol, just separating those 2 pieces out. And then we found it a lot more effective, and they were able to hang on to that a lot more. I would do a lot more of these with students though. I wouldn't just jump right into 0 pairs and exploring what that looks like yet. So in that previous question, we built 5 opposite 1, 5 -1. What was the mathematical representation that we used for that? Well, it was 5 plus 1. It made the same sense. I've got 5 piles and I've got 1 pile, because opposite 1 is the same thing as 1 pile. So when I take a look at this, when I've got the original statement I made that I provided you, and when you played with it and you ended up with 5 plus 1, what's that relationship between the 2? Can you see how those 2 are connected? And then giving students lots of time to engage in that conversation. Like I said, I'm going through this really fast because we only have 30 minutes, but you would be spending a lot of time here. I'm hoping that they're going to say, well, the -1 is the same as adding. Removing a hole is like adding a pile of sand, is really where we want to get them to. But the opposite becomes where it started in essence. And they're going to have lots of language around that. And I don't need anything. I'm not expecting anything formal in here yet. It's just that exploration piece. All right. So let's do some practice here. I want you to think about starting with 4 holes, and you want to remove 3 holes. What equation might you use to represent that? So you can draw it if you want, but see if you can represent it with using numbers and the addition sign and the negative sign here. Whatever would be most helpful. So you might have said 4 holes is -4, and removing is subtraction. 3 holes is -3. Now, does that look kind of like what we just did with the other question? Absolutely. And then once they've got it in this format, then they can start playing with what they've since made around piles and holes in order to figure it out. They don't have to think of this as adding the opposite. They can just think of it as I've got 4 holes and I've got 3 piles. in order to work with that. So when I do that, I'll end up with 1 whole. So how might you tweak this equation to avoid the use of those two symbols right beside each other? Well, the opposite of the opposite is like adding it. So then I can just play with it. The opposite of three holes is 3 piles. And then again, what's that relationship between the two? How can I clearly articulate why those two end up with the same answer? And I would never say, why are those two the same? Because they're not the same, but why do they end up giving me the same answer? All right. So again, if we were in person, we would have an opportunity to discuss some of these questions, and I'll give lots of opportunity to kiddos to do this as well. So let's take everything we've just explored. Why can 3 plus negative 2 be written as 3 minus 2? Well, if I've got my 3 piles and I've got my 2 holes, it's kind of like removing 3 of the piles. I used 2 of those, 2 of the piles. I used 2 of those holes to remove 2 of the piles to get into Zen state, and I was left with 1. And why can 4 minus negative 1 be written as 4 plus 1? Again, it's that same idea. So lots of opportunity for students to explore that. All right. What is the opposite of 3 piles and 2 holes? I'll give you a moment to think about that. And I'll even get you to write down the answer, or at least have it in your head. And you can write it as a number or in terms of piles and holes. So you will find when you do this, you will actually get 2 answers because this question is too vague. So I want you to think about how you thought of it. Did you think of it as, what is the opposite of 3 piles? And then the addition of 2 holes? Or did you think of it as, what is the opposite of both 3 piles and 2 holes? So what's the opposite of all of that? So I'll tell you, depending on which way you saw it, you either said your answer was 5 holes or you said 1 hole. So which representation gives you 5 holes and which representation gives you 1 hole? So the first bullet, the opposite of 3 piles would be 3 holes, and then the addition of 2 holes would give me a total of 5 holes. Whereas the second one, the opposite of both 3 piles and 2 holes, so I have to take the opposite of all of that. So 3 piles would be 3 holes, and 2 holes would be 2 piles. So I've got 3 holes and 2 piles, so I would end up with 1 hole, and then I can play with that. And some students might do they might do the 3 piles and 2 holes and then find the opposite of all of that, or they might do the opposite of each of those. And you might be thinking to yourself, that sounds an awful lot like the distributive property in order of operations, and it absolutely is. But it's really about bringing students' attention to which one are you going to do first? Why do mathematicians use parentheses to help clarify that? So that we don't accidentally make some of those mistakes. So when I take a look at this one here, I can very clearly figure out what's going on. So in this case, I've got the opposite of all of 3 piles and 2 holes. So then I can see what I would do there. Now, we would tell kids we would want them to do what's inside the parentheses first, and we would play with that. But I also want students to see I could look at the opposite of 3 piles and the opposite of 2 holes and do it that way, because as they go higher into more complex mathematics, they're going to have variables in there that they can't just add up what's on the inside, and I want them distributing to the outside as well. Okay, so here's the explanation of how that could be explained to students, and what is the relationship between that first representation and the second representation. And we don't ask that enough. We need to ask constantly. If I start with a representation and I change it, but they're still equivalent, what's that relationship? Why are they the same total value? All right, we're not going to get into this because I'm out of time, but here's some other opportunities for students really to sink their teeth into what does it mean when they have the negative on the outside of the parentheses, and how does that affect what's going on in the story and in the terms of piles and holes. And when they've got that story that they can attach it to, it certainly becomes a lot easier. All right, so I would take all of this and I would do pretty much the exact same thing using integer tiles. But then I can really dig into zero pairs in the integer tiles. I can too here, but I found it can sometimes lose people if we do it too soon. So just think about that, play with it. I will be putting this into our grade 6 number long range planning documents. Actually, I believe it's already there. I will fix the animations and fix that one where it shows the equals 4 in there. But then when you go to that long range planning document for grade 6 and you look at learner outcome 1, you're going to see a ton of things that you can do with integers, with virtual manipulatives, hands-on manipulatives, exploring with piles and holes. There's an amazing swimming pool one that I would start kiddos out with, which really gets into the sense of integers. I want to explore integers with all of that. Plus I want to do vertical number lines and I want to do horizontal number lines, as many different representations as I can, because when I have one representation, I've got a very not great hook into that concept. But if I do another representation, now I've got 2 hooks and it's a little bit stronger. 3 representations, the more representations I have, the more hooks I have, the more connections I have, and the deeper understanding students will have. This should take a long time. This is not fast. There should be no tricks and rules and just memorization of operations on integers, because that is going to not be helpful to students in the long run. Spend a little bit of time in the beginning of the year just exploring integers and what they mean in the sense of temperature and pH levels and things like that. And then dig into operations, but spread it throughout the year so that students have lots of time to really understand what's going on. All right, do I have any questions? I know it's a small group, but are there any questions for me? Okay, sounds good. So I want to thank you for joining me. I know it's tough to be at school or even at home and doing sessions after school. So I appreciate you guys being here. If you're watching the recording, I appreciate you watching the recording. If you have any questions, never be shy about emailing me. Take a look at those long range planning documents. There's lots in there as well. So we will see you next time.